Good morning, everybody. I put here just some random part of my long paper. I'm going to read it quickly and save you for boredom. And okay, let's go. I am Alessia Buffagni, PhD student from University Iuav of Venice. And these are the questions I'm trying to answer with my present work. This weirdo, instead, is the father of today's wearable technologies. In 1996, he said, "Our clothing will enhance our capabilities without requiring any conscious thought or effort." Putting aside for a while his vision of the future, let's see how, in the present, our capabilities are naturally going to fail. Falls is still the major cause of death from injury among the elderly. A big health issue, a huge medical cost. We see three levels of impact: in the person, in the environment, in the government. To prevent falls, 4 groups of intervention were defined. First, pre-fall prevention intervention system. For those people who have never fallen, we have gait and balance analysis and games and virtual reality for stimulating exercise routines. Second group is post-fall prevention intervention system. For people who have already experienced fall, which means in a riskier condition. We have, in addition, cognitive, functional, and environmental assessments. Third group, fall injury prevention system, which is a group of accessories to monitor activity, detect falls, and call for assistance. They can be user-owned devices and ambient-based devices. Last group, cross-prevention intervention systems. As the name suggests, is just a combination of the previous ones. Well, even if we have this well-supplied framework of system, still a limited attention has been given to smart clothing. According to Professor Tao, a smart cloth is a piece of fabric capable to react to external sources. She divides them into 3 groups of intelligence: passive smart materials, active smart materials, and very smart materials. After the development of the wearable motherboard, first picture on the left, which is the first smart cloth for military purposes with integrated conductive fibers, electronics into textiles found their home in healthcare and sportswear, like in the sports bra and in the Polotech shirt, with silver fibers woven into the fabric. In both, data is processed into an external device which needs to be attached to the garment, while a smartphone application returns real-time feedback. Same components design we find in the sporty smart socks by Sensoria. Speaking of socks, and specifically related to fall risk, this is a smart pair for hospitalized patient. Electroconductive fiber links pressure sensors on the bottom to the CPU on the top. When the patient hits the floors, the closest nurse is notified and ready to assist. Everything we have in the market today follows this same logic of composition. Conductive wires woven into textiles plus a rigid device to be applied to the garment. And attached to conductive buttons. That's why, for today's size batteries and chipset, which are bulky and rigid to ensure durability. To optimize dimensions, researchers from Sheffield designed a garment for hips protection with soft pads that cushion impacts and at the same time incorporate sensors. They are manufactured with Armogel. It is soft and flexible, but it hardens in response to shocks. And more results have been achieved lately about getting electronics more wearable. Trousers for fall detection, powered by printed batteries, have been developed by researchers from Slovenia just last year. Changing the user behavior through smart clothes may be another good approach to prevent falls. Postural control, for instance, is fundamental. A Dutch designer developed a smart top delivering haptic feedback when the user is slouching to induce a conscious change of behavior. Hence, there are also unconscious changes. Enhancement of balance has been observed in a group of elderly people thanks to show insoles that deliver a subsensory vibratory noise during the walk. According to Tao, what we have in the market today is active smart, clothes designed for reacting, but not yet for adapting. It takes a step further. We need them very smart, reactive in a more sophisticated way, in a kinematic, in a dynamic way. And just as Steve Mann said, without requiring any conscious effort or thought from the user. Joanna Berzowska introduced the concept of reactive and kinetic fashion. Within the context of fashion and personal expression, she developed garments changing shape accordingly to heat, electrical inputs, and body movement. To extend to other contexts and functionalities, we might include garments changing for human protection. Wearable airbags, for instance, by Denese, born for bikers and developed for older adults too. Or again, right for the elderly, this Japanese prototype of inflating vest. Wearable airbags have also been designed as belt-like devices, but we cannot call them properly smart clothes. They hint more to an accessory than clothing. Whereas shoes are definitely clothing. This is a prototype of balancing shoes from Israel. As a concept, it is a good example of kinetic support for older people who have no more the prompt reaction to perform the instinctive backward step once they start swaying. Even though it is quite rudimentary, this prototype deserves the credit for proposing itself as a substitute, or even better, an extension for a decreased or seized human instinct. Along with human instinct, aging brings away our musculoskeletal functions. Kinetic clothing are also the ones designed to react and adapt to certain body stimuli in order to provide a sort of compensation to human mobility. Aura Suit combines textiles and robotics in the declared intent to assist old people mobility. What if technology could help us continue to move about the world and engage with it physically, socially, and emotionally? This is the question Yves Bihar was trying to answer. His former partner, Rich Mahoney, while he was experimenting robotics for military purposes, ended up developing the seismic power clothing, a sort of reboot of Aura suit. He says, we were not innovating around robotics, we were innovating around clothing. Ideally, clothing should just enhance without restricting. Practically, designing for older adults implies to take account a great amount of factors, the very random combination of which we call aging. Clearly, we must assess physiological transition, many types of senses and skin disorders, delayed healing processes, and incontinence, of course, which is still the most common impairment among the elderly. It is not hard to see how the erratic combination of any of these factors draws a very tricky workspace for designers. Also, beyond physiological transition, we have also personal health conditions. Multimorbidity, combined with psychological and cognitive transition, have a substantial impact on functioning and quality of life. So, as Jen McCain said, we need a sensitive regard both to human physiology, feet, posture, thermoregulation, and above all, to psychological feel-good factor. To do so, a collaborative design approach involving users during the development helps to better single out that extremely fluid concept we call the user need. A focus on usability then, and a careful field research, spending plenty of time visiting seniors living communities, picking many and diversified cases of study, all in a fully collaborative perspective. This is likely the most recommended way to proceed, which sounds pretty obvious maybe, but in the end, as the most eminent philosopher of the change once said, it requires a very unusual mind to undertake the analysis of the obvious. And it is definitely an unusual mind that is required from designers to accomplish such a visionary task. Thanks.